Hello everyone, welcome to Equal To, and this is the fourth video of the first chapter of class 9 science number systems. So if you haven't watched the previous 3 videos yet, I'll give you a link, you can go and check that out. And in this video, first let me tell you what you have seen so far. So we have seen the types of numbers, that is natural numbers, whole numbers, integers and rational numbers, right? So that are the things that we have seen, and we have also seen few examples and the first exercise. All this have been completed. Now in this video we are going to see something called irrational numbers. So we know what rational numbers are, right? So what is a rational number? So a rational number is something that can be expressed in the form of p divided by q, where q is not equal to 0 and p and q, both these are integers, right? So this is the condition for something to be a rational number. Now we have something called irrational numbers. So it's exactly opposite to what rational numbers are. So irrational numbers are something that cannot be written in the form of p divided by q. So that is all the difference. Okay, so when it comes to the definition of irrational numbers, it's very similar to that of rational numbers, just opposite to that. So it cannot be represented in the form of p divided by q, where q is not equal to 0 and p and q are integers. So these types of numbers are irrational numbers. Okay, now a few examples of irrational numbers could be root 2, root 3, root 15, or pi for that matter, pi that we use, right, for circles. So pi is also a irrational number. So these are few examples of irrational numbers. Okay, I hope you are clear with this now. So irrational numbers are something that cannot be expressed in the form of p divided by q, where p and q are integers and q not equal to 0, and examples could be root 2, root 3, root 15, pi and etc. There are infinitely many irrational numbers as well. We know that rational numbers are infinite, right? There are infinitely many rational numbers, and so too is irrational numbers. Irrational numbers are also infinitely many in numbers. Okay, now firstly we know someone called Pythagoras, right? So I'm just going to write him in short. So Pythagoras proved that root 2 is irrational. Okay, now that is when he first proved that root 2 is irrational. Okay, so that is there. That is a factual thing. Now how did they actually come up with the number root 2? Okay, now that also lies in the above sentence. I have said you that Pythagoras proved root 2 is irrational. So we know that is there is a theorem which involves triangles, right? Specifically right angle triangle, right? What is that called? Pythagoras theorem. And what exactly is that? If we have a right angle triangle, the hypotenuse, which is this part, see, right? The hypotenuse is equal to square root of sum of squares of the other two sides, right? So in this example where we have this triangle, C is equal to square root of a squared plus b squared. Okay, so this is true. Now what if in this case, with the same example, what if the value of a is 1 and the value of b is again 1? Okay, in that case C would be under square root 1 squared plus 1 squared. 1 squared obviously is 1. So that gives you C's value as root 2. So this is how the Greeks came up with the value root 2. Okay, so this is how root 2 came into existence. Now that is not what you are focusing here. Now root 2 is irrational and Pythagoras have proved it. Now we know that all rational numbers can be expressed, can be represented in a number line. Can irrational numbers be represented in the number line? Yes, of course, irrational numbers can also be represented in the number line, and that is what we are going to do here. Now this is the third example in the textbook, which is you are going to locate root 2 in number line. Okay, now what we know already, we know that root 2 can be expressed as root of 1 square plus 1 square. So that is exactly what root 2 is, right? We just saw that root 2 is just root of 1 square plus 1 square, meaning it's just the hypotenuse of a triangle whose other two sides are 1. Okay, so this is root 2. Okay, we know this as well. Now we are just going to use these things to plot root 2 on a number line. So let us just first consider a number line, and let me have 0 here, 1 here, sorry, I wanted to write 1, 2, 3, okay, and to this side we have negative 1. Now we know that hypotenuse of a triangle, right angle triangle, where the other two sides values are 1 is root 2. The hypotenuse is root 2. So now we are going to use this. So we have 1 units here, right? Let me just draw it a bit more clearly. This is 1 unit, right? Now what I am going to do is that I am going to construct another line which is of 1 unit as well, which is perpendicular to the number line. Now if I join 0 with this is a hypotenuse, right? So this portion is a hypotenuse, and this value is 1 and this value is also 1. So let me just number this so it would be easier for you to understand. I'm just erasing this and going to number these vertices. So let this be 0, let this be A, and this one be B. Okay, OAB. Now we have a triangle which is a right angle triangle, OAB. That is the right angle triangle. Okay, now here OB is the hypotenuse. Okay, OB is the hypotenuse, and OA is equal to 1 units and AB is also equal to 1 units, and that tells you that OB is equal to root 2 units. Okay, so this hypotenuse would obviously be root 2, but it's at an angle. Okay, it's at an angle with the number line. We need to plot this in the number line, right? We need to plot this somewhere in this number line and not to an angle. So we need to have it here. So what you are going to do is that you are going to take a compass. You are going to keep the compass's needle at 0. You are going to keep the compass's needle at 0 and you are going to extend it up until B. Okay, so you are going to measure this OB with your compass. Okay, your compass's two ends should be, the one pencil end and the other one is needle, should be this length OB. Okay, with that you are going to place the needle at O and you are going to draw an arc. Okay, cutting the number line, you are going to draw an arc. I am just going to draw it roughly here. So you are placing your compass needle at O and taking the length of OB, you are going to cut an arc at the number line. Okay, now I have cut an arc here, and let us just say this is the point C. Okay, now we know that OB and OC have the same length. Okay, OB equals OC, it's the same length because if you just complete this circle, I'm sorry, it is not actually perfectly coming as a circle. Let me just grab another color. Now this circle is very rough. Okay, now let us just say it's way too off. Okay, so don't think too much about it. Now OB and OC, these are just radius lines of a circle. So let me just draw it somewhere else. Okay, I think you would understand it better then. So let us consider a circle, and from the center we have two lines. One, the origin, the center of the circle is O, one end is B, another end is C. Now we know that obviously OB is equal to OC, right? Why is that? So both these are just radius of the circles. So obviously OB is going to be equal to OC. So that is the exact same principle that we have used. We have measured the length of OB and cut an arc here. So the length of OB is going to be same as length of OC. Since the length of OB we know as root 2, that is going to be exactly what here is. OC is also root 2, and that OC is cutting the number line, and this is where root 2 can be marked. Okay, now the C is equal to root 2, the point that it has cut here. Let me just use a different color. This point that it has cut here is root 2 in the line. Okay, this is the root 2 in number line. I hope you understood what we have done. We know that if the two sides of a right angle triangle is 1 units, the hypotenuse's value would obviously be root 2 units. We have used that principle to construct a triangle right on the number line, and we have used the measurement of the hypotenuse to cut an arc at the number line, and that point would give you root 2 on a number line. Okay, so this is the concept that we are using. I hope you understood all these things. Now we are going to move to the next example that is very similar to this, which is locating root 3 on a number line. Okay, now in the root 2 on number line, we first expressed root 2 in the form of 1 squared plus 1 squared, and the square root of 1 squared plus 1 squared, and that let us draw a triangle with 1 and 1 as units. Now if you want to express root 3 in a similar way, how would that be? Now root 3 is equal to square root of root 2 squared plus 1 squared. Okay, now why is that? Root 2 squared is going to give you 2, right? Root 2 squared is 2 and 1 squared is 1, and that is how you end up with root 3. Okay, so if you were to assume root 3 as the hypotenuse of a right angle triangle, let me just draw a right angle triangle here. If you want this hypotenuse to be root 3, one side should be root 2 and another side should be 1. Okay, now only if this is thing, let me say this is side A, this is side B, and this is side C. Now C is equal to A squared plus B squared, right? Now A squared is root 2 squared and B squared is 1 squared, which would give you 2 plus 1, that is 3, right? And this is C squared, C squared is equal to A squared plus B squared. Now C squared is equal to root 3, that means C squared is equal to 3, meaning C is equal to root 3. Okay, so I hope this is clear. Now if you want to construct this, we know right after doing this, right after creating a triangle like this, it's very easy for us. You're just going to draw another arc measuring this hypotenuse length and an arc that is going to cut in the number line, and that would be the end of it, right? Now your task is to draw a triangle whose hypotenuse value is root 3. Now that is your task, right? So how would you draw a triangle with its hypotenuse as root 3? For that triangle, one side should obviously be root 2. I hope that is clear. Now for one side to be root 2, we have to first construct root 2. So this diagram, this what we have already done, you are going to do the exact same thing for root 3 as well. That is going to be your first step. You are going to create a triangle whose hypotenuse is root 2. Okay, that is going to be a first step. Let me just do that very quickly, because we have learned that already. You are not going to learn it now newly, so I am just going to draw it very quickly. Okay, now why am I always forgetting 1? Sorry. So this should be 1, the other one should be 2. Okay, now just again the same procedure, constructing a triangle. Okay, we have done the triangle. So this is O, this is A, let this one be B, and we know that this is obviously root 2. Now we have root 2. Okay, now this side, right, we have this side and that is going to be our this side. Okay, so that we are going to assume it as this one, and what you're going to do is that you're going to use this as one side and construct another side perpendicular to it. Okay, now we know this line should be perpendicular to this line because Pythagoras theorem only applies for right angle triangle. So since we have root 2 here, we should need a side at this point only, then we can construct a right angle triangle. Okay, so I am going to draw a line which is of 1 units in length, vertical, exactly vertical, 90 degrees to it. Now this also is 90 degrees and that also is 90 degrees. Okay, and if you join this, one side is root 2, just like this triangle that we have seen right here. One side is root 2, another side is 1, which means this side should be obviously root 3. Okay, so this one should be obviously root 3 because one side is root 2 and other side is 1. Now after doing this, it's very same to the previous one. We are going to measure here from here. Let me just mark this. Let this be point C. You are going to measure from O to C. With that in compass, you are going to cut an arc, cutting the number line, and that would give you root 3 on a number line. Okay, now I think this B might be quite intrusive. Let me just wipe that out, and with this I am going to draw an arc. Okay, and that is going to be root 3 in a number line. Okay, I hope you understood this as well. You are just going to construct root 2 first, and using that you are going to create the root 3 on number line. Okay, so creating root 2 is the first step for root 3. Okay, I hope you understood this and you are clear with this. Now, yeah, I think that is it for this video. If you have any questions, please put them in the comments. I will get back to you as soon as possible. And thank you so much for watching this one. See you in the next one. Bye for now.